I'm here to talk about thermochemical waste conversion technology. This is the beginning of a research project that I'm just at the early stages of, involving so far interviews and a lot of textual analysis. And I won't be talking too much about methodology, but I'd be glad to do so at the end. So what is thermochemical waste conversion? Well, it refers to a set of practices and technologies and machines that basically take any waste that contains carbon and applies heat, and in some cases a catalytic reaction, to create end products that are used as fuels or building block chemicals. And these products are completely compatible with the products that are derived from petroleum and coal and natural gas. They're completely compatible with the hydrocarbon and the petrochemical economy. And with regard to municipal solid waste, these technologies have a lot to work on. 85% of all municipal solid waste, at least in the United States, are carbon bearing, and I would be surprised if it were substantially different in Canada. And this holds true even after recycling and composting is taken out. There's still very large quantities of biogenic and synthetic carbon-bearing materials in municipal solid waste, and all of these are feedstocks to thermochemical conversion. Now, applied to municipal solid waste, these technologies usually go by the umbrella terms waste to energy, or more recently, energy from waste. And they can take two forms. The familiar combustion or mass burn that all of you probably know well takes carbon-bearing wastes and substitutes them for natural gas or coal in a power plant, a utility plant, and uses the steam that's produced from the heat to spin a turbine to produce electricity. New and emerging conversion technologies are somewhat different. They use higher temperatures and less or no oxygen to produce a range of intermediate and final goods that can be used to produce fuels of all sorts, for jets, for automobiles, for diesel, as well as petrochemical-like substances that can be used in feedstocks in basic chemical processes that undergird our material economy. And the producers or the vendors of the mass burn technologies are groups like Covanta and Wheelabrator, well known in North America, whereas the new and emerging folks have yet to actually build and operate a full-scale functioning facility, but there's a great deal of investment and excitement and activity and interest and huge amounts of venture capital being thrown around in this area. And in Canada, probably the best known example is Glasgow, which is a gasification facility in Ottawa. Now, both types of waste to energy are at the moment in a period of attempting a comeback after seeing a contraction in their industry from the 1990s to the 2000s. And there are a number of reasons for what are referred to in this source as setbacks, having to do with economy and comparative costs of fossil fuels. But, and I'll be talking also about the social movements as the reason why these industries have faced a setback. But you can see that there is very rich and fertile ground for expansion of waste energy in both the US and Canada, where a very relatively small fraction of disposal is being carried out through this method as opposed to in Europe. And both recycling and composting are making some progress, but still by no means addressing most of waste management needs. Now, I mentioned social movement opposition. This has been built up over the decades, starting with the anti-toxics movement in the 70s and the environmental justice movement that started to emerge in the 80s. And here in this shot, you see contemporary opposition to a conventional mass burn Covanta facility in Ontario. It's jerks like you who keep healthcare cause harm, you have poisoned us. They're referencing risk, health risks from the residues of thermochemical conversion. And this is an argument that has been very well established and worked up and is still quite potent. And it's articulated in the context of siting inequity, as well as an overall critique of the corporate profits that accrued from waste management to these large facilities, and the fact that they need to have a certain quantity of waste to work on consistently. And this critique of them is called feed the beast. The idea is that you will not be reducing waste because you need to guarantee a certain feedstock. These are all very well established arguments, and they've been very well studied in the sociological and other literatures around social movement opposition to toxics. But what I want to know in the area of waste energy and its renaissance or potential renaissance in North America is what we can say or understand about what is new. Right. This lecture series is called Waste and Indeterminacy. And there are a lot of scholars who are arguing that indeterminacy and related concepts are characteristic of our time. That we are entering, or we're at the beginning, or maybe we're in the middle. It's very hard to know without looking back historically. But that we're entering a qualitatively different epoch. You know, the Anthropocene is another way of describing it. And this epoch has all sorts of features to it. And so my question is the comeback of waste energy in some way different? And can we understand this difference through some of these concepts? Now, one much more concrete way in which our current epoch is different is that we have the crisis of climate change that we're coming to grips with. And earlier in another presentation, someone else used the term waste energy nexus. There's a lot of interest in research and government policy around the relation of waste to climate change. And concurrently, there's also an understanding of a nexus between climate change and energy security requirements here in North America. And these are often talked about interchangeably, but are actually quite different concepts. So you have the goal, sort of the diffuse goal of greenhouse gas mitigation, usually through the substitution of energy inputs through some kind of fuel switching that is being pursued at all sorts of scales, not necessarily nationally in each country, but regionally and locally with various carbon credits and trading schemes, as well as even voluntary acts. And then there is the notion of energy security, so domestic sources of energy. We need to reduce our reliance on foreign oil, et cetera, et cetera. So this perspective would equally support things like the tar sands or fracking, or other forms of energy that are called renewable because they're not finite. And within renewable, we have things that some would call true renewables, which are solar and wind and hydro for all of its problems, as well as biomass, which waste energy sort of falls into. Its biogenics part does. And combined, these are two very potent arguments that can be brought to bear in favor of or by the waste energy industry to position itself as offering both domestic, so secure energy, as well as energy that saves greenhouse gases. And that is exactly what's going on by the waste energy industry and the Energy Recovery Council, which is their main trade group. So the waste energy industry today is marketing itself as what I've said. And it's interesting to look at how the biogenic and the synthetic fractions, the things that lived recently versus things like plastic, which were derived from things that lived a long time ago, fossilized, are are thought of and dealt with in this equation. So under waste energy, the biogenic fraction of municipal solid waste is renewable. Why? It's renewable because it grows, right? The idea is that you burn it and it will grow back again. And it is greenhouse gas neutral because it's considered a wash. The carbon dioxide that is reduced from thermochemically treating biogenic fractions of municipal solid waste would have happened had the growing thing fell on the forest floor and rotted away. And this is a very important argument that the industry is making in the United States, and I believe also in Canada, from state to state or province to province, to argue for renewable energy credits to be applied to municipal solid waste conversion. And there is also a supplementary political goal of including plastics in that definition, if not as greenhouse gas neutral, then nonetheless renewable in the sense that garbage is inevitable, right? So garbage is a renewable resource in the sense that it is constantly or always arising, or at least a certain amount of it will be. And in this rhetorical work, which is already, as I hope you can see, is starting to borrow heavily from discourses of ecological modernization that have to do with addressing climate change. There's also an explicit tactic for the waste energy industry to position itself against landfilling, to condemn landfilling as an ecologically harmful and irresponsible and wasteful practice. And it's interesting that voices like Covanta will do this even as they are subsidiaries of larger waste management conglomerates like Waste Management Inc. that are operating landfills simultaneously, but they maintain enough of a distance to evince this critique. And what they're saying is that waste energy is able to capture the embodied energy in goods and not to waste them, as opposed to placing them in the landfill where they will do no economic good to anyone. So to summarize, the industry is saying it offers greenhouse gas mitigation on 3 levels. First, it is substituting for coal and oil. Second, it is avoiding the landfill methane that will be released when materials are otherwise landfills, even with landfill capture and utilization, which is not as efficient. And third, the secondary metals that are sifted out of the ash from the processing or the char, the slag, are going to be delivering greenhouse gas mitigation benefits down the line by substituting for raw materials. And this is an argument, this is a very familiar argument for recycling, which is the recycling movement and recycling proponents traditionally position themselves against waste energy, but they all point out that recycling saves greenhouse gases because, for the reasons mentioned here, it breaks off the need to go backward in the commodity chain, and then it also requires less energy to process secondary inputs. Now, in the face of this, what I would call increasing sophistication on the part of the corporate tactics or the industry tactics, we're also seeing increasing sophistication among the social movements who still continue to unilaterally oppose any form of waste energy, traditional or new and emerging. And this is a very strongly, commonly held view among everyone in the environmental justice movement, everyone in the zero waste movement, most environmental organizations, although not all. A line is absolutely drawn beyond which any type of thermal application is opposed. But the opposition, it has gone from stop, don't build a facility, it's going to poison us, although that is still being articulated. But on top of this, we have more subtle and nuanced concern over material trajectories. So no longer are social movements talking in abstract about the fact that feeding the beast means that we have to live forever in a throwaway society. They are looking at pressures and opportunities for ecological modernization to realize itself through process and fixed infrastructure. So here are some of the ideas that are being thrown around by social movements. That this is Paul Connaught, a very famous chemist and an opponent of waste energy based on risk, is talking about the fact that waste energy preempts circular economy. Moreover, the Product Policy Institute, which is a major EPR advocate in Canada and the US, is talking about how the lock-in of material flowing to a waste energy facility is going to lock out pressure for redesign, as Virginia was talking about earlier in her presentation. So there's the notion of wrestling for control over material trajectories. And yet within the zero waste movement, there's also a counter group that is fiercely critical of EPR as being a potential backdoor to incineration, so that when corporations, whether collectively or individually, take back their products, it may be more economically advantageous for them to thermochemically convert them. And this has led to fierce internecine schisms in the zero waste movement, with those who favor only grassroots approaches to transforming materials into materials, calling the others EPRistas and advocates of waste energy in disguise. And even within this constellation of approaches, we also see even some progressive voices starting to come out in favor of waste energy. Not a lot, but some. And strangely converging discourses from the waste energy or the biofuels industry itself. A reason to love waste is that residues can be used over and over again. Waste from one process can be the feedstock to another. There's no limit to ingenuity. And they're emphasizing the many uses out of the one original aggregation of organic molecules. So once again, biogenic, synthetic. I can't emphasize this enough. So I don't have a lot of time, but what I've been thinking about these days is something that has been alluded to in all sorts of different ways in talks all through this series, but what I would call material transitivity. And it's nothing more than basically a restatement of the first law of thermodynamics, or the old folk statement that there's no such thing as a way. We are still grappling in the current era with the fact that if we want to wash the tar off our hands, we can't really do it, right? We're smearing it onto something else that has to go onto something else, just like this poor bird. Right? We are still playing a policy of shuffle and dodge, which the early incinerator proponents talked about. And this has very much to do with what we've been talking about with waste is liminal, right, is this movement. But there's also a really core biophysical aspect to it, in that what is being negotiated here by waste to energy is the subsumption of biogenic and synthetic carbon-bearing materials back into the hydrocarbon economy. And that is basically, at core, the most radical critique of waste energy. I'm not going to read through all of this, but it has to do with material trajectories and not wanting them to go towards an outcome that is going to support the continuation of a hydrocarbon economy. The most radical critiques of waste energy are ones that are actually about energy and not about waste so much, saying that as long as biomass and waste energy is a form of this, or at least part of it overlaps, exists, we're not going to get to solar, wind, and hydro, because there are going to be spatial and infrastructural and political and economic constituencies that have built roads and infrastructure and momentum and stickiness that are going to prevent us from going forward. And so I want to end with a pragmatic challenge to those of us who study waste in relation to climate change, which is the problem of our time, I would argue, along with biodiversity loss. We need to think, when we're thinking about waste, about whether it is possible to transition from a hydrocarbon economy in the near term, and if so, what are our materials, because that's what we're interested in as waste scholars, what are they going to be made of?